So today's challenge is to push deep into understanding even further about this topic and how it works. Trust me, it's going to be very wild. You're going to love this. Our main reach is to help you improve your mathematics. Okay, let's get down to business. So today we are going to be finding the derivative using two ways, of which one is using first principle. Remember, never ever use first principle unless you are told so. Today we are going to be finding the derivative using two ways, of which one of them is first principle and the normal way. And remember, only use first principle if you are told to do so. And normally, in my experience, when you are required to use first principles, the marks will be around 6 or 7 marks. But if you are required to use the normal way, marks are normally around 3 there. Whenever we speak about derivative, you must think about associating with gradient. So remember how we use changing y over changing x for 2 points. When deriving, we try to narrow down the value of h. Okay, what you should note is that derivative is like finding a gradient. So whenever we speak about derivative, think of gradient associated. Remember how we used to find a gradient given 2 points using the formula changing y over changing x. Well, now imagine if you are required to find a gradient on a tangent. Remember, a tangent from circle geometry, we know that it's a line that only touches the circle once. Tangent is that line that cuts a graph at only 1 point. And then for those who don't know, we have a line that touches a graph at 2 points, known as a secant. This is the line I am talking about. So when we derive, we try to narrow the value of h from this formula here. This is the formula for finding the gradient of a tangent given 1 point. So this is how the formula is. And then when we're deriving it, it brings us here. The gradient is equal to f of x plus h, of which is the value of which is this here. Let me show you. This is the f of x I'm speaking about. So this is the value of x here. So this is the f of x plus h minus f of x. This is the formula. And then when we simplify this formula, you know this x will cancel this x. You can see here, it will bring us here. So when we simplify this formula, gradient is equal to f of x plus h minus f of x over x plus h minus 1. So this is a given formula. You always find this on your formula sheet. When we use this formula to find the gradient, we are deriving. Derivative is literally using this formula to find the gradient of a tangent given 1 point. One thing you should note is that if you are told to apply first principle, make sure that this lim as h tend to 0, you apply it further down up until where you remove this h here. So there are rules and ways on how to get to this step. So this is what we are going to be doing in this video. So it might sound complicated, but don't worry. This is what we are going to be doing in this video. I'm going to show you where and how to drop this lim as h tend to 0. So there are key aspects of this topic that I really want you to know, which are laws of calculus. So I'll be exploring each and every single law. I will explore the first one, give an example, do the second, give example, and so on. Okay, let's start with the first one. The first one says that if you are given f of x equal to k, where k is a constant, the rule of derivative says that the derivative of a constant will always be equal to 0. Let's say we are given f of x equal to 5 and we are required to find the derivative of f of x. The derivative of constant will always be equal to 0. And then moving to the second one says if f of x is equal to x to the power n, then the derivative will drop n and then x to the power n minus 1. Okay, let's say we are given x to the power 2. What I mean is that you will drop that 2 here, and then you get 2 times, you don't remove, you drop it, and then it still stays. You have 2x to the power 2 minus 1. This is what they mean when they say the derivative of x to the power n. You drop n, and then x to the power n minus 1. And then moving to the next one, if you are given f of x equal to a coefficient times x to the power n, the derivative will be coefficient times n, meaning we still drop that n and then multiply by x to the power n minus 1. So the only thing we do here is that we still drop that one and it multiplies that coefficient that we have found there. So for example, let's say you are given 10k to the power 3, meaning it will be, you still have your 10, you multiply by 3, and then you still have your k to the power 3 to the power 3 minus 1, which it will be 30k to the power 2. And then the very last but not least is that if you are required to find the derivative of two functions, so sum of, what I mean is that the sum of these two functions, the derivative of f of x plus derivative of g of x, the sum will be equal to the sum of derivatives, meaning we must first find the derivative of f of x and then find the derivative of g of x. And then what you should note is that you must not remove this expression for as long as we haven't taken out the derivative. Meaning if we haven't solved this derivative fully, you must not take out this expression here. So let's say we are given this example here and say find the derivative of dx, where we are given 2x squared minus x minus 15 over x minus 3. So the first thing you should know is that you cannot differentiate if you have a denominator. So what I mean is that you may not differentiate when x is the denominator. What you can do is you write it as, let's say you have 1 over x, you can write it as x to the power negative 1. You know, when you bring x to the numerator, it changes the sign of the exponent. So the first thing you should know is that you may not differentiate if you are given brackets. The first thing you should multiply out and simplify your expression. And then the second one is this one that says you may not differentiate when x is the denominator. That's where I say you bring your x up. And you may not differentiate when the x is a set form. So if you are given set form, you can remove that set form. In this way, let me show you how you can simply remove your set form, meaning your square root. Let's say you are given 4 root x. We all know that root x means we have x to the power of goes 1 here, and then that 2 there. And then if it was cube root, we know it was going to be 3. Now let's deal with if it's a square root, and we know there's 2 here. What we mean if we say you can't differentiate when you are given a set form is that you must make sure that you change these two. 4 times, you write your square root as x to the power that goes 1 here over that 2 there. So the reason why I show you this way is because I don't want you to get confused if you are given something like 10 times m root x to the power n, and then you are required to simplify this. So you apply the very same rule that I applied there. You just simply take your 10, you multiply by your x to the power n, and then you divide by your, whether it's a square root or is m root, you divide by that root there. That's what I mean when I say you cannot differentiate if you are given a set form. And then from here, you can apply that rule where you have a coefficient, a x to the power something, and then you know that what you do is you are going to multiply your 10 by your mn, and then you have your x to the power n m minus 1. That's where your rule will apply. I'm sure now it makes sense now that we're applying rules. And then also dy over dx, meaning find the derivative of y in respect to x. So if you are given dy over dk, meaning find the derivative of y in respect to k. So let's say you are given 3k to the power 4 plus 2k to the power 2 minus 5 plus 7. It's asking us to find the derivative of y in respect to k. So we are going to apply the simple rules that I told you. So meaning from this first one, we are going to apply the rule that we have a constant and our n here. So we are going to say with this multiply by 3, and then we have our k to the power 4 and then minus 1. And then coming here, we are going to have this multiply our constant. We are going to have 2 multiplied by 2 to the power 2 minus 1, and we are left with 1. And then we are going to have 5 multiplied by 1 here, and then we have our k, and then plus, remember, derivative of constant is 0. It's important that you put this 0 to show that you know that the derivative of a constant is 0. And then deriving here, you know, simplifying all these simple steps, you just simplify here. It will bring you to 12k to the power 3 plus 4k minus 5. Okay, now let's go back to our equation and try to find the derivative applying the very same rules. Okay, so we are going to simplify 2x squared minus x minus 15 over x minus 3. What we already know is that we cannot derive if we have a denominator. And then from here, you can simply see, or even if it's not that easy to see, but you can note that we have an expression that we can factorize and then try to cancel out that x minus 3 so that we don't have a denominator. We can try to simplify, factorize, and cancel out that x minus 3 so that we don't have denominator. Okay, trying to find the factors, we are going to find the factors of 2 and 15, that when we add them up, they give us this middle number here. Factors of 2 are 2 and 1. Then factors of 15, we have 5 and 3. Okay, when multiplying 2 and 3, it gives us 6. And then when multiplying 5 and 1, it gives us 5. So 6 minus 5 gives us 1. So okay, we can simply take these vectors because they really fit. Okay, we are going to have our first bracket and our second bracket. So we're going to have x minus 3 into bracket and then 2x plus 5, because one should be positive and one should be negative. And then from here you can see that this x minus 3, you can cancel out x minus 3. When factorizing, I know we apply different lot of skills. Some use a calculator. You can also apply that. The main point is to find the factors that will help get rid of the denominator. And then from here, we are left with 2x squared plus 5. And then we can simply now derive that. We simply have our expression as dx into 2x plus 5. And then we can simply derive this 2x plus 5, which we can now drop our expression and derive 2x. We'll have goes to 1 times 2, applying the rules is 2, and then x and then that 1 minus 1 is 0. We know the derivative of constant is 0, and then 1 minus 1 is 0, and then any number to the power 0, anything to the power 0 is 1. So we're going to have our derivative there. So meaning the derivative of this whole expression is 2. Now let's try some examples using first principle. If you are told to apply first principle, this is what you should do. If you are given f of x equal to 6x to the power 2, and we are required to determine the gradient on a curve at point x equal to 1. The first thing you should do always is to write down the formula you are given. The formula will help you to drive you towards the last answer. And remember, do not remove this limit as h tends to 0 up until you derive your answer. This is where I will apply it and you'll see what I mean. So the first thing is to write down the formula, determine f of x plus h, and determine the f of x, so that you can come back and substitute them on this formula. So let's determine f of x and f of x plus h to find the gradient at a curve, given that x is equal to -1. So our x, given that is going to be -1, our f of x at -1, we are going to simply substitute that -1 from our formula, and then we are going to be given 6 into -1 squared. -1 squared is 1, and then we are going to have 6. So our f at x is given to be 6. Now we have the value of f at x. We can now calculate the value of f at x plus h. So meaning where we see x, we put x plus h, and then we are told that our x, we are calculating our gradient at x equal to -1. So wherever we see the x, we put our -1. F at x plus h will be 6 into -1 plus h squared. And then we are going to simplify this. It will give us 6 minus 12h plus h squared. And then we are going to take these two, f at x plus h and this f at x, and we're going to substitute them on this formula. Remember, we are going to drive through this distance with limit h equal to 0 up until we derive this problem. Therefore, we'll have f at x plus h minus f at x over h, and then we substitute our fx plus h, which will be our 6 minus 12h plus h squared, and then we substitute our f at x, which will be our -6 because of this negative sign here, and then we have our h. Don't forget, we have h as we are trying to find the limit as h tends to 0. And then from here, you can see that this 6 will cancel out this 6. We are going to be left with -12h minus h squared. And then from here, we can simply factor out the h, and then we'll cancel out. We are left with -12 plus h. So from here, you can simply say that our limit where our h tends to 0, our gradient where our h tends to 0 is 12. So let's try second last one. I hope from here you'll be having a better foundation of this topic. So here we are given f of x at -x cubed plus 2x plus 1. We are required to find gradient at point x equal to 1. Remember, we were using 2 points using changing y over changing x. Now we are finding the gradient using only 1 point. So we are given x at 1, and we still can find the gradient using calculus. So the first thing you should do is to always write your formula. It will help you to simply substitute your values right here, and then there's always a mark for that. So just copy that formula from your formula sheet and put it there. And then from here, we are going to determine the value of g of x at x plus h, and then the value of g of x. So since we are told that we are finding the gradient where x is equal to 1, we are going to come here and say, we are going to say g of x where x is equal to 1, and then we are going to write that equation we are given and substitute 1 everywhere we see x, and then substituting 1 here, and then when we do so, the answer you get is 2. So meaning g of x where x is equal to 1, we get our 2 there. Okay, and then g of x plus h where x is equal to 1, we are going to come back to the formula, and then wherever we see x, we put our x plus h cubed plus 2 into x plus h plus 1. But we know our x is what? Is 1. So wherever we see x, we substitute with the value of 1, and then we're going to substitute from there. And then simplifying this one, I'll leave it to you to practice. And then simplifying this one, you will get 2 minus h minus 3 h cubed minus h. Remember to always write limit up until we reach the second last step. From the values that we found, we can come here and substitute our g of x at 1 plus h and our g at x at 1. Our g at x plus h and our g at x over h. And then from here, we have these values here. And our g of x, we have 2 minus h minus 3h squared minus h cubed. And then our g of x, we have minus 2 all over h. And then from here, we can see to cancel out 2. And then we'll have negative h, negative 3h squared, negative h cubed all over h. And then we can factor out our h. And then from here, we can cancel out. And then we have negative 1 plus 3h plus h cubed. Remember, we factored out the positive h. And then we factor out h, we'll have negative 1, negative 3h plus h squared. Negative 3h, negative h squared. And then from here, we can say that our gradient as lim tend to 0 is our gradient as h tend to 0 at this limit is negative 1. I will leave you with this one, and then you can comment your answer in the comment section. So I want you to find, given the function f of x is equal to 3x squared minus 3x plus 8, use the simple not first principle just to derive this function here. And then the last one, given function f of x equal to 2x squared minus 5, I want you to find the gradient of a tangent on a curve at point x equal to 2. And then I want you to use the lim method to solve this equation. Thank you so much for being here. I really appreciate you. If you find this video useful, make sure to subscribe, like, and smash that notification button to make sure that you are well notified and updated each time we upload a video.